So DC machines. A DC machine is the same machine can be act as a DC generator or a DC motor. That means the constructional point of view in DC generator and DC motor, there is no difference. But if the input power is mechanical input, then it is a DC generator. If it is electrical input, then it is a DC motor. A DC generator can convert mechanical energy into electrical energy. The mechanical input power, we can say the power P equal to T omega, that is torque into angular velocity. The torque and angular velocity is produced by the prime mover, and the electrical output is here P equal to VI. Here there is no cos pi because of DC generator. So if it is a DC motor, the electrical input power, that is P equal to VI, is given, and then the DC motor gives the output power P equal to T omega, torque into angular velocity. Electromechanical energy conversion. So here only the machine can be convert the electromechanical energy conversion or the mechanical electro conversions. So it cannot be a DC generator, it cannot create, but it can convert the power. Here is, according to Einstein, the energy cannot be created and cannot be destroyed. It can be converted from one form to another form. So here also a generator and motor can convert the energy from one form to another form. Here only conversion is taking place. So it is maybe a electromechanical energy conversion or the mechanical energy electrical conversion. So ideal electrical machine, electrical system, see the figure, V supply is given, then the I current flows in the machine, the current I flows in the machine, then the machine converts its electrical power, that is volt ampere, into mechanical power, that is torque into angular velocity. So energy flows from, if it is a motor, outside to inside. If it is a motor, the power flows from outside to inside of the machine. If it is a generator, the power flows from energy, certain energy flows from inside to outside. Here, if it is an ideal system, because of ideal system, the input power and output powers are same. The input power and output power is same, equal. So here is the input power volt ampere and output power is the torque into angular velocity. So electrical energy, or we can say electrical power, is equal to mechanical power, torque, angular velocity. So for a electrical system, voltage is input, current is volt and current. A mechanical system output is the torque, angular velocity. Because of it is ideal, because of it is ideal system, there is no losses, the losses are zero. Now the classification of motors. Classification of motors. The electrical motors. The electrical motors are alternating current motors and direct current motors. So we can say AC motors and DC motor. The difference between AC motor and DC motor is only the supply. If input supply of the machine is a AC, then it is a AC motor. Then if it is a DC supply, then it is a DC motor. If output generated by the generator is a AC supply, then this is a AC generator. If DC power is generated, then that is a DC generator. Sorry. A AC motor are again three types. One is synchronous machines and asynchronous machine. The asynchronous machine also called induction machine. And third one is the universal machine. A universal machine, it can be works for AC and DC supplies. So again, induction machines are single phase and three phase induction machines. Okay, asynchronous machines which runs at one speed, that is called synchronous speed. But induction machines are runs at other than one speed, that is called asynchronous machines. The meaning of synchronous is the stator flux speed and rotor speeds are same. If stator flux speed and rotor speeds are same, then it is a synchronous machine. If stator flux speed and rotor flux speed are not same, then it is a induction machine. In a universal machine, here there is no stator flux rotation. It is a pulsating supply. So there is no rotating magnetic field. So the universal motors are, it can be operated at with AC and DC supply. And highest speed machines are universal machines. It is up to 10,000, 5,000 RPM, revolution per minute. So the universal machines are highest speed rating machines. A direct current machines is the DC motor. So the topic is DC motor. DC motor. Features of DC motor. The DC motor features are, most of the electrical machines in service are AC type. So mostly we go for the AC machines because AC supply is generated, and worldwide the power supply generated by the generators are mostly in the power plants are AC power. Or AC power. It is because of, we can study, I will give the clarification in the working of DC generator. Because in the DC generator, if you generate a large power by the DC generator. Large power by the DC generator. There is a commutation failure. The commutation segments, between the commutation segment there is a mica insulation. That mica insulation damages, so we go for AC power generation. Because of there is no commutator in a AC machine, we go for AC power generation, not DC power generation. Large rating of power generation is best suitable for AC power generation, not a DC power generation. So when we need a small amount of power, so kilovolt, not up to kilo, some volts of the volts, so 500 volts and up to 1000 or 800, 500, 600 volts, we go for DC power generation. So DC machines are of considerable in industrial importance. So here a second point says that DC machines are considerable in industrial importance. So the mostly DC motors are used in industrial because of a DC motor speed can be controlled easily, because the frequency is 0 in a DC motor. So input power is a DC. At DC input frequency is 0. Because of frequency is 0, the speed controlling is easy. So for a better speed controlling is possible by the DC machine. So for all industrial applications, a DC machines are best suitable. A DC machines mainly used as a DC motors, and the DC generators are rarely used. So a DC machines, in the DC machines, a DC motors are mainly used. DC generators are rarely used because of we can't generate large amount of power by the DC generator because of commutation failures and insulation failures between the commutator segments. A DC motor provides a fine control of the speed which cannot be attained by AC motors. DC motors provides a fine control of the speed which cannot be attained by the AC motors. In AC motor, so the fourth point says that in a AC motor the speed controlling is not that much easy because of frequency is not equal to 0. Because of frequency is not equal to 0, frequency is not equal to 0, so it is difficult to control the speed. Because frequency is proportional to speed, F proportional to Pn by 120, the frequency is proportional to speed. So in AC machine frequency is not 0, so it cannot be controlled easy in AC machine. Fifth point, a DC motor can develop a rated torque at all speed from standstill to rated speed. So the highest torque produced at starting and running and standstill condition, at all speed conditions it can be produce a higher torque. And a DC series motor gives the higher torque in all motions. So the DC series motors are used in traction motors. Sixth point, developed torque at standstill is many times greater than the torque developed by an AC motor of equal power and speed ratings. So this is the advantage of DC motor again. Standstill means zero speed condition. That means the machine is going to run. The speeds are increasing from zero. That time is called standstill time. So the applications of DC machines. So here these are the advantage and features of the DC machine. So we go for DC machines. So application of DC machine. The DC machine can operate as either a motor or a generator. At present in its use as a generator is limited because of the widespread of use of AC power. DC generators are rarely used because of commutation failures. So large DC motors are used in machine tools, printing presses, fans, pumps, cranes, paper mills, traction, textile mills, and so forth. Small DC machines are fractional horsepower rating machine. That means small HP machines are used primarily as a control device such as a tacho generator for speed sensing and servo motor for position and tracking, and used in robots. Advantage of DC machine: high starting torque is available in a DC machine. A rapid acceleration and deceleration. It can be runs quickly, and decelerate means it comes to the zero speeds or minimum speed easily. Speed can be easily controlled over widespread range, so it can be controlled from zero speed to higher speed, and more than a rating speed also it can be possible in a DC machines. Used in tugboats, traction motors, electrical train, electrical cars, built in wide range of sizes. Disadvantage of DC machines: needs a regular maintenance. So brushes and commutators has to be maintained regularly because of commutator. Maybe at commutator the current reversal takes place from DC to AC. So in that place because of current reversal there is a sparking occurs between the commutator and brushes. So the mica insulation may be damages. So because of mica insulation damaging, so we need to regular maintenance brushes and commutators. And the more armature in any machine, we have the two winding, armature winding and field winding. But in armature winding is high power circuit and field winding is a low power circuit. But in all machines except in DC machine, all AC machines, a armature winding is on a stator. But in a DC machine, armature winding on a rotor. High power armature winding on rotor. So the rotor rotates. So armature winding is on the rotor. So there is a insulation may be damaged because of high power machine. High insulation is required. Higher insulation may be damages because of it is unrotating part. So we need a regular maintenance at armature winding insulation also to check insulation of armature winding. Cannot be used in an explosive area. This machine short cannot be used in an explosive area. And higher cost because of commutators are more. In AC machine there is no need of commutators. So the cost of commutators are high. So the cost of the DC machines are more. So now construction of DC machine. A cross section of a 4-pole DC motor is shown in the figure below. So see the diagram and draw the diagram. We can see the flux lines. So you can observe the 4 poles and 4 slots. Here 4 poles, 2 north poles and 2 south poles. North poles are opposite, south poles are opposite. So here we can observe the 4 flux lines, 4 separate flux lines, closed circuit lines. So here a 4 flux lines, so that we can say the 4 magnetic circuits. We can say a 4 magnetic circuits. Okay. Here the flux produced by the poles is a pi. The flux produced by the pole is a pi. The flux produced by the pole is a pi. Then the flux carries by the yoke is a pi by 2. Pi by 2. Pi by 2 means the yoke carrying the half of the flux. See the air gap. The air gap is between stator and rotor. And the rotor also called the armature core. Armature core is laminated. Yoke is not laminated. And pole core is not laminated, but pole shoes are laminated. Pole shoes are laminated. So we go for a brief discussion of each part. So the mainly outer layer is a frame or yoke. If it is a AC machine, we can say that frame, stator frame. But because of DC machine, you go for a yoke. Yoke. The first point is a yoke. This is the outer part of the DC motor. Outer layer of the DC motor. It provides the mechanical support for the pole. It provides a mechanical support to the poles. And it acts as a protecting cover for the whole machine. It carries the magnetic flux produced by the poles. Yokes are made out of cast iron or cast steel. Cast iron or cast steel. Field poles. Field poles are mounted inside the yoke, are made up of thin lamination stacked together. It consists of pole cores and pole shoes, as shown in the below figure. So the pole core and pole shoes, we can observe the area of pole shoes are more than pole core. It is because of the field winding is wound on the field winding is wound on the pole core. So if field winding is wound on the pole core, the pole shoes provide a mechanical support to the field winding. If pole shoes area also same to the pole core, then the field winding may be comes from the pole core, and the pole shoes area is more than pole core because it spreads the flux uniformly in the area. The field poles are mounted inside the yoke, are made up of thin lamination stacked together. It consists of pole core and pole shoes as shown in the figure. The pole shoe serves two purposes. They spread out the flux in the area, and also being the larger cross section reduce the reluctance of the magnetic path. Thus the main turn length of the wire will be reduced. Thereby it reduces the weight and cost. They support the field coils also, and it spread the flux uniformly in the area. Field winding. Field winding is a shunt field winding and series field winding. Field coils are wound on poles. These are the two types of field winding. Shunt field winding, a large number of turns of small section copper conductor is used. It is connected in parallel with the armature winding. Series field winding, a few turns of heavy cross section conductor is used. It is connected in series with the armature winding. A DC motor may have both field winding wound on the same pole. If it is a shunt motor with only shunt field winding. Series DC motor, the motor with only series field windings. Compound DC motor with both field windings, shunt and series field windings, mounted on the pole core. Armature core, it carries the armature winding, is made up of sheet steel lamination. The laminations are stacked together to form a cylindrical structure as shown in the figure below. Laminations. Draw the diagram. So we can see the slots and teeth area. So this is slot area. Air gap is more for slot area and air gap is very less for the teeth area. So slot area air gap is more, so at slot area reluctance is more, at teeth the reluctance is less. Armature winding is the heart of the DC motor in which torque is developed. So this is the armature winding. We can see the commutators also here. Iron core coil. Next one is the commutator. The commutator whose function is to facilitate the collection of current from the armature. So see that commutator is a copper segment, hard run copper segment. It is a commutator is made up of hard run copper material, but armature core is made up of silicon steel, sheet steel or silicon steel. So these are the armature windings. The function of commutator is to collect the current from the armature. It consists of copper segment tightly pasted together with a mica insulating separator on an insulated base. The whole commutator frame forms a rigid and solid assembly of insulated copper strips and can rotate at high speed each. The commutator segment is provided with a riser where the ends of the armature coil gets connected. So see that here commutator 1 to the middle segments is called the commutator segments. Outer coils are the armature windings. So we can see the minus and plus, that is the brushes. Armature commutator in two-pole DC machine. Brushes are the elements which are connecting the armature windings through the commutator to the external terminal of the motor. The brush pressure on the commutator should be just right, because low pressure leads to poor contact, which results in excessive sparking and burning the commutator, while high pressure lead overheating the commutator. Principal operation of DC motor. In a DC motor, field force are supplied by a DC excitation current, which produce a DC magnetic field. Armature winding conductor is supplied by a DC current through the brushes and commuters. According to Lorentz force equation, a current carrying conductor placed in a magnetic field, it experiences a force. That force is called the Lorentz force. Due to that force, it tends to move it as shown in the figure. All the conductor placed on the periphery of the DC motors are subjected to this force. This force causes the armature to rotate in a clockwise direction. Therefore, the armature of DC motor rotates in the direction of the torque developed by the motor. Left hand rule say that the direction of force and direction of magnetic field, direction of current, back EMF. Due to rotation of the armature coil, that is the conductor in the magnetic field, a motor works as a DC generator and induced EMF act as a in the circuit. This opposes the current. This induced EMF is called a back EMF EB. EB equal to K pi omega m. K equal to PZ 2 pi A, machine constant. P equal to number of poles. Z equal to total of armature conductors. A equal to number of parallel paths in the armature. A equal to P in case of lap windings. A equal to 2 in case of wave windings. Pi equal to flux per pole in Weber. Omega m equal to 2 pi n by 60. N is the armature speed in revolution per minute. EB equal to n pz pi by 60. It means pi zn by 60 into P by A. EB is produced by the generator action of the motor. So the back EMF is the EMF it produced in the motor. So to understand the back EMF is called whenever a DC machine running as a motor, whenever a DC machine running as a motor, then the conductor on the rotor, that is armature conductor, cut by the stator fluxes. The armature conductors on the rotor cut by the stator fluxes. Then EMF induced in the armature conductor is called back EMF. Actually a DC motor. In a DC motor there must be a generator action. Due to generator action, the back EMF produced in the machine. If it is not produce a back EMF by the machine, then the machine will be burned because of the current drawn is more. If there is no back EMF, the current drawn is more. If the current drawn is more, then armature may be heated up and it may be burned. So the back EMF is very important in the DC motor. So the types of DC motors: separately excited DC motor, so we go for the topic is again the working of DC, principle of operation of DC motor. So give supply to the field windings and place and give supply to the DC supply to the armature winding also. Whenever a DC supply is given to the field winding, there is a magnetic field is produced in the machine. A magnetic field is produced in the machine, and whenever a current supply is given to the armature winding, then the conductors of armature conductors are carrying the current. These armature conductors are there in a magnetic field, so it experiences a force. The force F equal to BIL sin theta. Then machine can be continue to runs. The direction of machine can be found by the Fleming's left hand rule for a DC motor. For DC generator, it is a Fleming right hand rule. For a DC generator, Fleming's right hand rule. Left hand rule for a motor. So it is very important. Field poles are supplied by the DC excitation current, which produces a DC magnetic field. So armature winding is supplied by a DC current through the brushes and commutator. So according to Lorentz force equation, a current carrying conductor placed in a magnetic field, it experiences a force. That force tends to move it as shown in the below figure. The machine will be continue to rotate. All the conductors placed on the periphery of the DC motors are subjected to this force. This force causes the armature to rotate in a clockwise direction. Therefore, the armature of the DC motor rotates in the direction of the torque developed by the motor. So we can observe that thumb direction is the force direction, middle finger direction is the current direction, and the forefinger is the magnetic field direction. A DC source voltage is given minus and plus. Then the current carrying conductor AB, the conductor AB carries the incoming current, and CD carries the outgoing current. We should remember that for a motoring action, the conductor which comes under north pole must be a cross conductor. That must be a incoming current. It's very important that the conductor which comes under north pole must be a cross conductor. It always, at any cycle, it can be possible by the commutators only. And the conductor which comes under south pole must be a dot conductor, that means outgoing current. So it can also be possible by the commutators. In place of commutator, if you use the slip rings, the conductor which comes under the north pole is cross at half cycle and dot at other half cycle. So because of cross and dot alternating changes for every half cycle, so the machine produces a bidirectional torque, so the machine will not rotate. So a DC motor need a commutator to maintain a cross conductor under north pole and a dot conductor under south pole. To maintain a cross conductor at the north pole and dot conductor at the south pole.